embarking on lessons 105 through 108. Lesson 105 corresponds very closely with what we did in some previous lessons where we've used exponents. And we have discussed the importance of using care when using exponents. So if we have parentheses around the number and the negative sign with an exponent, that means that exponent applies to the negative sign as well as the number. So in our first example, we have -3 to the second power. So that means we're going to say -3 times -3, which equals +9. Whereas on the next one, the negative sign is not included in the parentheses. So we would read that as the opposite of 3 squared. Well, 3 squared is 9. So if we wanted to write it out, we'd write it like this: the opposite of 3 times 3, or -9. Okay, so you see the importance of those parentheses. Now, when we're using substitution and we're evaluating for a variable, it works in an interesting manner, okay? So here we have a being -4. So that means that if we substitute -4 for a in the first equation, it's as if that -4 is in parentheses. Okay, because a is being squared, so the -4 is being squared. So that would equal 16. In the second example, we have the opposite of a squared. Well, we know that a squared is 16, so the opposite of that would be -16, but let's write it out. It would be the opposite of -4 squared. So it would equal -16. I would like for you guys to do the rest of those examples, those practice problems on your own. Actually, let's go ahead and do one more because they do get more complex, don't they? So we have a squared minus a b squared minus b squared. All right, and we are told a is -2 and b is -3. Okay, so if a is -2, we're just going to substitute a -2 for our a's and -2, and then a -3 for our b's. Now notice I'm putting my negative and its value in the parentheses, but the minus signs I'm not putting in parentheses. So -3 squared. Okay, so -2 squared is -2 times -2, two negatives multiplied together equal a positive. So we have +4 minus, let's just do the exponent, -2 times, what is -3 squared? -3 times -3 is +9 minus, once again, -3 squared is +9. So now we can do the multiplication in the middle. Remember, we need to get that multiplication done before we add or subtract. So we'll rewrite everything else. 4 minus, well, -2 times 9 is -18 minus 9. Now we can resolve our double negative and cross it and make it positive, because it's the opposite of -18, which is +18. So now we have 4 plus 18, which is 22, minus 9. Well, 22 minus 10 would be 12, so we know it's going to be 13. Okay, so I think you can do the last of those on your own. Let's move on into lesson 106. Lesson 106 is related because it's talking about roots, negative roots. So it says we've been using negative exponents when practicing scientific notation, but in this lesson we're going to look at it in a different way. So what is the following in standard notation? We have 9.25 times 10 to the negative 3. Well, we've talked about when we have a negative exponent, we want to make our number smaller. So we're going to take the decimal and move it to the left 3 times because that will definitely make it smaller. So in standard form, that would be 0.00925. Okay. So we've looked at these as moving the decimal to the left, which means we must be multiplying by what fraction? Well, we're multiplying by 1 over 1,000. That's how we end up moving the decimal point over to the left 3, because really we're dividing by 1,000. So looking at the 2 examples I have there, 10 to the 5th power equals a 1 with 5 zeros, 100,000, and 10 to the negative 5th power equals the reciprocal of that, 1 over 100,000. All right, so let's look at the examples, and these I've numbered, thankfully. It's helpful when I number them. So look at example number 1, and it's talking about the cubed root of negative 64. Well, if you have made that chart that I told you to make about a month ago, you will know that the cubed root of negative 64, well, we know that the cubed root of 64 is 4. So now we just have to think about this. If the cubed root of 64 is 4, then what's the cubed root of negative 64? It would be negative 4. And we can check it. Negative 4 times negative 4 times negative 4. Okay, well, negative 4 times negative 4 is 16, and that times negative 4 will get us negative 64. All right, so we're set. So we can find a negative root of any root that is odd. So 3 is an odd number, and so if we have a negative underneath a cubed root or something to the 5th power or the 7th power, then we are able to find that. But not so if it were the square root of negative 64, because negative 8 times negative 8 is positive 64. And so we couldn't have found it if it was like that. All right, number 2. I'm going to let you do 2 and 3 and 4 on your own because you have your charts. Those should not be a problem for you. But let's look at example number 5. So it says 1 over 4 to the negative 2. Well, we know that a negative exponent is just telling us to do the reciprocal of that. So what is the reciprocal of 1 over 4 to the negative 2? Well, it's 4 squared. All we did was get rid of that negative exponent. All right, and now we can square 4 and we'll get 16. Okay, how about number 6? It's 1 over negative 2 in parentheses to the negative 4th power. Well, in order to get rid of that negative sign, we have to write the reciprocal of 1/2, essentially. So it becomes negative 2 what is negative 2 to the fourth power? Well, it's negative 2 times negative 2 times negative 2 times negative 2. If you look at your chart that you've created, or you may already know it, we know that 2 to the fourth power is 16, and negative 2 to the fourth power will also be 16 because we have an even number of negatives, and those negatives create positive numbers. Let's look at number 11. We have x cubed, y squared, x to the negative 2, y to the negative 1. Well, in our previous lesson, lesson number 101, we talked about when we are multiplying variables with the same base, we can add the exponent. So we could write this as x to the 3 plus negative 2 times y to the 2 plus negative 1. I'm going to write that a little bit more clearer. Okay, so 3 plus negative 2 is 1, so we don't need to write that. If our exponent's 1, we don't have to write that. And our exponent for our y will also be 1. Okay, do number 12 on your own because it's similar to this one that we just did. And we will definitely go over those in our class on Wednesday. Lesson 107 is on Roman numerals. And some of you have had exposure to Roman numerals and others of you haven't. Those who have not had exposure, you do need to go ahead and work on learning these. Take a look at that chart. You have the symbol. The symbol for 1 is I. The symbol for 5 is V. The symbol for 10 is X. 50 is L. 100 is C. 500 is D. And 1,000 is M. So the Romans did not use place value, and they had no symbol for 0. So what they did was they wrote their numbers as a combination of letters that would add up to what they wanted. So for example, if they wanted to write the number 1, they would write I. If they wanted to write the number 2, they would put 2 I's together. 3, 3 I's. 4 would be special. It's 1 less than 5. So they would put an I and then a V. So if the I comes, if one letter comes before another like that, it could mean that it's 1 less than that number. Because we already said that 5 was V. So 6 is going to be V plus 1 more. V, I. 7 would be V plus 2 I's. Okay, 8 would be a V plus 3 I's. So you see, if the I's come after the V, we're adding them. If they come before the V, we're subtracting. So 1 less than 5 versus 1 more than 5, or 2 more than 5, or 3 more than 5. And then when we get to 9, 9 will be 1 less than 10. Okay, so I've already covered 4 and 9 in those examples. Let's look at that first one, that's 3,493. how would we write that in Roman numerals? Well, we know that 1,000 is M, so we need 3 of those. And we're going to start with the largest place value. And then we want 400. Well, 400 is 100 less than 500. So we'll put D because C is 100 and D is 500. So because the C is coming before the D, we know it's 100 less than 500. And then 93. So 90 is 10 less than 100. So we'll put XC for 90. And then 3 is 3 I's. Okay, so then we have some that say write the number represented by the following Roman numerals. So our first one is D, C, C, L, X, I, V. So D is 500. The 2 C's would be 200. So we can think of it as 500 plus 200. L is 50, so plus 50. X is 10, so plus 10. And IV, 1 less than 5, is 4. So it would be 764. All right, and our last lesson, so for those of you who've never had any exposure to Roman numerals, I'm sorry, you're just going to have to work at it. And you can get some extra practice online. You can get extra videos online, but more than anything, it's memorizing the symbols that go with what number and figuring out how to use it. So for lesson 108, fractional percentages. So remember, when we change a fraction to a when we change any number to a percent4% per hundredth. So we need to divide by 100 whenever we do this. So 4.2%, well, divide by 100, it means we move our decimal to the left twice. Because when we divide something, we shrink it, right? So as a decimal, it would equal 0.042. What about 0.05? 0.05 would equal we got to move it twice to the left. So 0.05% would equal 0.0005. Very small portion. We will do the other two in class together on Wednesday. Including that story problem. So I would like for you guys to do that on your own. 4.5% of students said they did not brush their teeth every day. Yuck, don't be like that 4.5%. If there were 1,200 students in all, how many did not brush their teeth every day? And then go ahead and complete that table. I don't tell you what to write in it, do I? Oh yeah, I do. I have the 0.04%. So I need you to write that as a decimal and then write it as a fraction. You can take the decimal number and read it. So let's just do that one together. So 0.04% as a decimal would be 0.0004. And we know that that's tenths, hundredths, thousandths, 10,000ths. So we can write it as a fraction as 4 over 10,000. Can that be reduced? Yes, it can. We can divide by 4, and we get 1 over 2,500. Okay, so I do want you to finish that chart, and anything you don't understand, we will go over together in class.